Okay. Assalamu alaikum, everyone. How are you doing, guys? I hope you have practiced enough for the previous three sessions that we conducted. We conducted two sessions. So I hope you guys have practiced enough for those sessions because you are going to need a lot of knowledge, information from those sessions that we are going to present today. Okay. I don't see the screen here. Okay. So that's a little bit of introduction. You all know me, Muhammad Adeen. I'm a PhD student. Yeah, so without wasting any time, I will just move on to my scheme of the presentation. So we have already discussed all of these topics in the previous sessions. Like we have discussed how to name variables, what are variables. We have already discussed data types. We have discussed functions and operators as well. So today we are going to talk about loops and condition statements. So let me move towards loops. Okay, so loops basically allow you as a developer to avoid writing statements multiple times that you want to be executed multiple times. So the idea is very simple. You write the statement once, but you execute it maybe 100 times. I don't know. It depends on your requirement, what you want to do. So loops basically are available in every programming language, as you know. And the basic purpose is that you execute a set of statements or a block of code multiple times without writing it again and again. So how many loops you can have? You can have for loop and you can have a while loop. And you can have nested loops. So there can be loops. It's simple. The idea is that you have a loop within a loop. So it's called a nested loop. And the basic difference between a for loop and a while loop is that a for loop requires an iterable. So anything that is countable, anything that you can count is an iterable. So we have already seen the types of counterables in our previous session. A list presents a number of items. So those items in a list are countable. Also, a string is combination of letters, so they are also countable. Whereas in while loop, we only check the condition. If the condition is met, you execute the body of the loop. The body is something that you want to execute after the condition is met. So the body is written inside the loop. Once the condition is met, that body will be executed. And if that condition is not met, that body won't be executed. So let me move on. So this is just a basic flow chart to show you how loops work. So as you can see here in for loop, what you're doing is you're looking for iterables, countables. For every item in that iterable, you go inside the body of the for loop and you perform some tasks. You execute some set of statements. You go back, you check again if the iterable is there. So you keep in the loop. If you find nothing, you just exit the loop. That's it. In a while loop, the structure is the same. Only difference is that you check for a specific condition. If that condition is true, you go execute the body. If that condition is not true, you just exit the loop. So let me move on towards Python so we can have a hands-on experience with loops. So here I have already done a very short example of a loop where I only print numbers from 0 to 10. So here I have said for I. So I is just a name of the variable. You can choose any name you want. You can choose any name you like. So it just has to be a variable and it has to follow the conditions of the variable names. So in is saying whatever is on the right is a countable thing. You have to pick numbers from there or the set of items. So you will pick items. So it can either be a list, a set of numbers, For example, here, when I say range 10, what range 10 does is it returns me a set of numbers that are iterable. So you can go on counting the numbers. So if I say here range 10, so it means I have to go to up to 10. I will start from 0. So any programming language, it always starts from 0. And then it goes to specified number. So here in Python, we have already established that we always go to 1 less the final number that we have stated. So if I say 10, the last number will be 1 less 10, and that is 9. So what happens here is that, so I print it here, I run this. So what happens? It counts from 0 and it starts printing the number 0, 1, 2, 3, 4, and it goes till 9. So it stops at 9. So after 9, when it goes back to look for the iterable, there will be no iterable because there is no 10 in the list. So it will just simply exit. To see that, so, and in Python, I have already told you that indentation matters. So you can see here. Let me write it again so you can see it. So let's say for I in range 10, and this sign colon is very important here in loops. When you press enter, you see what happens here. It automatically did an indentation. So it means you're going right. So you're going in the right direction. But if I forget, somehow I forgot this column, you see there is no indentation. So it means you have done something wrong. So you have to go back, put the column, come back. And then you have to do your task, whatever you want to do. So let's say I just keep it simple. I'll say value of I equals, I put a comma here and then I put the number here. And then I press enter. So you can see there is another automatic indentation here. So it means you are inside the body of the loop. So the body of the loop starts from here. And if you want to go out of the body of the loop, you just need to go back and you do your work here. Let's say you print loop exited. So let me run this. So what happened here was that when it reached 9, after that it went back to look for iterable. It didn't find any. So it moved towards exiting the loop. It exited the loop and then it executed this statement. So it's told you loop exited. So that's very fine. Okay, so that's an example of a for loop. So a little bit more knowledge on this function range. I've already told you that you can check any function in Python by just looking for help. So let me say range. Okay, so we have talked about this function in our last session. One thing is that you can enter in, you can start, you have to enter a stop button. So you see here, if I have only one argument inside range, it's a stop sign. So it will always start from 0. If I enter only one number, it's a stop. So it will always start from 0. If I enter start and stop, so let's say I don't want to start counting from 0. I want to start counting from a different number. So I have to specify this number here. I have to specify start here. I have to specify my stop. And then you have a step here. What does this mean? This third argument, step, it means that you don't want to add 1 to start every time the loop executes, but you want to add a different number. It can be any different number you want. So every time the loop will be like this. So first time you will get start. Whatever is in start, you will have it. Next time will be start plus step. So let's say this is 1. I go from 1 to 10, and I say a step of 2. So first value is 1. When it goes back to execute the loop, second value will be 1 plus 2. It will be 3. and so on. So we can see this here. Let's say I start from 1 to 10, and then I have a step of 2. So you see 1, 3, 5, 7, 9. So you always add 2 here. And here you can have any number. It doesn't have to be 2. You can even have 0.2. What happened here? Okay, it said float object cannot be interpreted as an integer. But I don't understand what is the problem. It shouldn't be like this. Okay, anyways, let's try to solve this problem here. So if it doesn't work for you, I can try a new statement here. So I say I equals 1.2, and I say print value of I. Let's see. Okay, it works. So it should also work for this one. The problem is, seems to be here in the for loop and the range function. Let's do it again. So to see the numbers coming from a range function, we have to convert it to a list first. So I'm putting here list function, and then I put my range function. And let me just copy this. So the problem is with the range, not with the. Anyways. Let me try a different number. Okay, I don't know what is the issue exactly. So it is supposed to work. Okay, so for example, here it tells you, if I have range ij, it produces numbers starting from I, and then it will add 1 to, and it will go to j minus 1. And that's we already know. And by default, it will start from 0 if I don't provide I. Yeah. So, yeah, you know that. So these are exactly the values for a list of 4 elements. Yeah. And when a step is given, it's just specified as an increment or a decrement. So you can even have, you can even count backwards. So you can use a step of minus as well. For example, here, let's try to avoid this. So let's say you want to count backwards. So you start from 10, you end at 1, and you count backwards. So this is minus 1. So now you get a list of numbers starting from 10 and you're counting backwards. So you go till 2 because here I provided 1. So if I put 0 here, it will go to 1, of course. So you go to 1. Okay. So pretty much we understood the for loop, and there's a problem with this float that I don't know what is the issue here. But okay, if I put here, okay. So let's go to while loop. So in the while loop, I have already shown you that a while loop is there to check for a condition. So it will move into the body if the condition is met. If the condition is not met, it won't move. So let's say, let's suppose we ask the user to enter a number. Let's say a num. So input. Let's say I'm saying this, your number here. And then we want to show him a count starting from a specific number till that number, So let's say if user enters 10, we want to count starting from 0 till 10, and at 10 we want to stop. The while loop provides us with a very good execution time here. Like it's easy to implement instead of for loop. So I say here while, then I put my condition here. So I say, let's say while number the provided number by the user is less than, let's say we want to count to 10. So never forget this column here. So I put enter, and then I say print, let's say your number added 1 is, so what I will say here, I will say give me the number. Yeah. So let's say we add 1 to the number. So here it will be like this. So we have already talked about this one, the assignment operator coupled with the arithmetic operator. So I put here 1, and now let me run this. So we want to count till 10. So I should provide a number that is below 10. So let's say I put 2 here. So what happened here? It says this operator less than is not supported between instances of a string and an integer. So we have already talked about this thing in our previous session, that this number here, 10, is considered an integer. And when you input a number from a user, it's considered as a string. It's not considered as an integer or a float. Python doesn't know what is it. So Python takes it as a string. So what you have to do is you have to convert your number to the input string to a number, to an integer. So what I will say is that convert my input string to an integer. So let me enter 2. So you see now it worked. So here you can see another thing, that it counted till 10. I provided 10 here. So what happened? When it saw that the number is 2, so I provided 2, yeah, as an input. It went here, it looked for this condition, and it checked if 2 is less than 10. Okay, this will be true. So when this is true, it executes the body of the while loop. It goes inside, it adds a number, and then it prints your number here. And then it goes back. So now your number is 3. So 3 is always less than 10. So it will do the same thing, and it will go till 9. Okay, so we will expect it to stop at 9, but why didn't it stop at 9? So when you have 9 here, it goes back. This number 9 is less than 10. So it comes here, it adds 1 to 9, it becomes 10, and then it prints this number and it goes back. So now 10 is not less than 10, so it will exit the loop. But it printed 10 here because of this. So you can play with these statements to, so let's say, what I do is that, this, I just change the statement, the order of the execution of the statement. So let's say I change this string. So let's say we say counting from your number to 10. And then let's put a colon here. So execute this one. I say here 2. Yes. So now you see, now the last number printed is 9. It's not 10 anymore. Because of this statement, because I moved this statement, I changed the order of the execution of these two statements, and the results are totally different. So you should also know how you want to see the output. Based on that output, your execution of statement should be ordered. So you can see here, by just changing the order, I change the output. So this is a very interesting phenomena from programming languages. Why did it happen? Because it first printed the number, then it added, and then it went back to check on the condition. So the last number, when it printed 9, so here it printed 9. Then it went here and added 1, and it becomes 10. Then it goes back and looks for the condition, and the condition fails. So here it will return false. So it will exit the while loop. It will not go inside the while loop again. So that's how you can have a different output based on just the order of the execution of your output. So we have talked about for loop. Let me answer this so you can see. Okay. So we have talked about for loop, and we have talked about while loop as well. And you can see here that by just, for example, in the while loop, you can see by just changing the order of the execution of the statements, you can have different outputs. And also another thing that you can see is that in a for loop, you need an iterable. Another thing that I want to let you know is that this statement here in is another kind of operator that we didn't talk about last time, but you see it now. So what happens here is that when I put this in here, this in looks for the next number provided by this function. So every time it will iterate and look for the next number, and it will assign that number to this variable I, and then you can do some executions. Okay. So, okay, I have told you that this for loop works on countables. So let's have a look here. So let's say you ask the user to input a string. Okay, so I put a string here. Then I say input. Your string here. So now you have the string provided by the user. And let's say you want to print the same string, but you want to add a new line after every letter that you print. So it's very simple because you know a string is a countable, so you can use the for loop, and you can just say for. Here you can use any variable. It's just a dummy variable, so you can use anything. So for I in here you have to put your variable string, and then what you have to do, you just have to write your print statement. Print. And another interesting thing that you can do here is that you can even count the letters for the user. So let's say I introduce a variable here. Let's a counter. Let's say x equals 1 because so for the user we start from 1. So you say your first letter, your second letter, your third letter. So you say here your letter, and now you want to incorporate x in here as a string. You cannot. So if I put x here, this is a string. This is not a variable. But you want to print it as a string. What you can do here? There are two things that you can do. You can do string concatenation that we have been doing. So what I do here is that, and whenever you do string concatenation, it will add a space automatically between the strings. So let's say I do this like this. Then I put a comma here, then I put my variable x. Then I put a comma here. So it will be like your letter 1, and then you have to put a string here. So you put a space. And then you say is, and okay, what we like to do is add these. It looks good. So you put here I because you want to add the letter, and then you can say the same here. Yes, and you can go here and you can say print. You can say simply here done printing. So let me just run this one for you. So I enter your string. So let's say my string is Python tutorial on. Let's say this one is the third session, so we say 3. Okay, nice. So run this for me. Oh, sorry, I forgot. So I have to press enter. Yeah. So now you can see what happened here. You see here it added one space by default that it should add, but here it added 2 spaces because okay, it added only 1 space, but I had provided space here, so it becomes 2. Okay. What happened here was that we were not counting this string, so that's why it printed 1 1 1 all the time. So what we have to do is we have to set a counter. So I just say here. So now what will happen? It will set a counter and it will give me right numbers. Yeah. So now you get right numbers here. So it counted. So X is now X is a counter for you. This is one way to do it, this thing. Another way to do it, and it can avoid you writing these two statements. It's very simple. You just let me just copy paste so you can see better. I don't know if I can remove this so much. So anyways, let's see this. So what you do here is you remove this line. You remove this statement as well. And then here we are going to use a function called enumerate. So very good thing to know about if you are working right or not in Python is this, that you always get colors. So you see, as soon as I wrote enumerate, it highlighted it with a green color. Print is highlighted with a green color. So input. So 4 is as 4 as well, and this in. So you know that you're doing good. You're going in the right direction. So that's a very good way to know if you're programming good or not. So what this enumerate does. What it does is that it starts counting whatever is provided inside. So it will give me the letter as here. So we got this letter. as well the number of the letter. So all I have to do here is that I have to put x comma I. Let's run. And I give the same string here. So you see, now you are getting the same numbers. The only difference is that you get this number with 0 instead of starting from 1. So you can make it start from 1, just put a 1 here every time. So you see, now you got it from 1 to 19. So you see, by just doing simple tricks, you can avoid writing more lines of code. So we avoided 2 lines here. So that's very important when you're doing programming as a developer. You need to keep your code as much short as you can. You need to avoid writing huge number of lines. So it's very important. Okay, so we have done this. Now we can move on towards nested loops. Nested loop are nothing but it's just a loop inside a loop. So let me write the same loop here. And let's think of an example. Let's say you want to do 2 counts. So let's say you have 2 variables, x and y. And for every count of x, you want to add another variable y to it. Or maybe it will include also, let's include a list so you understand more better. So let's say I have a list. So I always use this variable for a list. You can use anyone. But avoid writing this list, because if you write list, you see it's colored. So list is a function, built-in function provided by Python. So you want to avoid, never name your variable with anything that turns green. So just avoid it, so what you can do to avoid it is just add an underscore here. So now you see it's not a Python function anymore. So anyways, these things you learn with experience. When you work, when you practice, you will learn these things. So let's think of a list here. So let's start from true, false, 0. Let me say 1. Let me say a string here. And another interesting thing is that in a list can also be a part of a list. So here I can even enter list here. Another list, you see. So I say 12, 13, 14. Okay. So now what I want to do is that for every item, let's say we call it an item. So this thing here is called an item of a list. So we can call it an item. For every item inside this list that I have provided L, when I put this, let me say print me the item. Yeah. Okay. So I say item. I just enter item here. So now we want to do something. For every item in list, you want to do something. Yeah. So let's say for. Now you have to put a for loop. So I don't know what you want to do. Let's say for I in range. So let's keep it shorter so we just go ahead with it. So I will say here 3. Print number I is, let's say this, comma I, comma this. Okay. So now you have a for loop inside a for loop inside a for loop. And so here I will print another for loop, another print statement. I will say, let's say outer loop, because once you remove this indent, you are inside this for loop, which is the outer loop. and this for loop is your inner loop. So here you can also do this, print inner loop, so just to see the output. And then finally you exit the outer loop and you say, just say exit all loops. Yeah, okay, so let me run this. So you see what happens here. So your first item was true, and then you go inside the inner loop, then you start counting the number. So you see here, you're printing this inner loop every time you're counting the number. You can avoid this. So let's say we want to print this once only. So here, what you can do is you can introduce a conditional statement. So let's say I put if, and then I say if I equals 0. So only for the first condition. I put a colon here. I press enter. You see there is another automatic indentation here. So you're inside the body of if. You have left the body of for loop. So you are inside the body of if. So let me just do it like this and run. So you see now it printed only once. So that's nice. So you see inner loop, then you print 3 numbers, then you say outer loop, then you print your item, then you go through inner loop and you print 3 numbers. And finally, when everything is done, you come here and you say exit all loops. So these are 3 things that you have learned today: for loop, a while loop, and a nested loop. You can even nest a while loop inside this one. So all you have to do is this. Let's say while. But that for a while loop, you need to set up a counter. So here I say always put I equals to 0. Start from 0. And here I have to check the condition. So I say I less than 3. So first, when it comes inside the loop, your I will be 0. Then it will print this statement, and then it will come out and it will print this statement. And here you have to set up the counter. So you say I plus 1. So next time this statement won't be printed because I will not be 0. So run. So you see you get the similar output, but with a nested loop using while loop instead of for loop. So if you want to use while loop on a counter, you have to do it like this. So you see you have to add multiple statements. So you have to add like this statement here, and you have to add this statement here. So you have to add 2 extra statements that you can avoid by just writing for statement. So that's how you can change how you want to enter a loop. Okay. So let's move towards our next topic of today. So today we have to talk about this one. After loops, we will talk about conditional statements. You have already seen one example of a conditional statement that if the condition is met, then execute that block. Otherwise, don't. So if you have only one condition, that's called an if statement. Okay. If you have another line of code that you want to execute, if that statement is not met, then you use this one, if else. So if this condition is true, do this. If not, then do another thing. But if you say, okay, do this only if this condition is true, you just put if. But if you have 2 statements for the same condition, then you have to use if else. But if you have multiple line of blocks and you have multiple conditions to meet, then you have to use this one, if, elif, and else. So we will talk about, and I will show you examples. So actually what this if else tree does is that it's helping you with the decision making. So your program is kind of making a decision based on some criteria. Yeah? And similarly, your if else statements can be nested in a similar way as you did with the loops. So this is just a simple flowchart just to show you that in your if, only if you are using only if. So you check that statement. If true, you execute and then you exit. So here it should go here like this. Yeah. Okay. Yeah. So there should be a straight line here. So you should exit. And if false, you should exit. You don't do anything else. But here you start, you check your condition. If your condition is true, you execute the body of if. If it's not true, you execute another block of statement and then you go to exit. So you see how you can do the difference between two. So now let me move towards Python. So yeah, let me just rewrite everything for you. So we don't have to do this again. So I will just skip this here and then I will move towards if else statement. So you have already seen one example of if statement here. Okay, so let's say we are building up a calculator and we want to do some operation based on the input from the user. So you want to do addition, subtraction, multiplication, and all the arithmetic operations that you can do. So let's choose 3. So today we are doing 3 steps. Yeah. Oh, let's start with example of 2. So then you can see how it moves. So let's do plus or minus. So we are building a calculator that can only do plus or minus. Yeah. So what you have to do is let's put this inside a function so you have a more better idea. Yeah. So def, I'm using this calculator here. And then what I do is, the first thing is that you ask the user for the number. And then you say, enter first number. And then you do the same thing. You ask them for the second number. And they will store that inside another variable b. So here I will do, let's say, second number. And not to forget, you have to convert this string to a. So we are hoping that the user only enters the integer. So I'm converting this to an integer. Int a, and you can do the same here. In b, yeah. And then in the third thing is that you ask the user for the operator. So what do they want to do? They want to add or subtract. So input, enter, let's say operation as. So I do this here, plus, or let me say minus. So the user will tell you if he wants to add or subtract. Yeah. So now you have two conditions to. Okay, you have already only one condition. You have to say that you have one condition. Some people will see it as a two conditions. Some can see it as a one condition because they are contrary to each other. So because user can only enter plus or minus, so they are contrary. Yeah. So if you enter plus, you have to add. If you enter minus, you have to subtract. Yeah. So let's say we say here, if my operator, and then I compare it with if plus. Yeah. And then what I say here is that print, let's say result equals. So let's say we say it like this. Result. You want to also say this A. Okay. So A, and then you want to add this plus sign here, and then you want to say B, the letter B is your number. So you say result A plus B, and let me add this sign here, string equals, and then you do the, so you are doing summation, so you should simply do this, A plus B. Yeah, fair enough. And the second condition is that they can all ask you for a minus, and simple as that. So you say here else. So if the user asks you to add, you go here. So this will be true. And if this is false, it means they asked you for a negative. Yeah. So this, you can do both things. You can either put if, and you can check your condition with a minus. But you are smart. You don't want to check it again because you have already checked it once, and that's a computation cost that you have. So you don't want to do it again. So you just say check it once, and if not, then just simply do a minus. That's it. So this should be a minus B. Okay, I run this. What I do here is I call this function. So I enter my first number. Let's say my first number is this. My second number is this. And now I want to tell them what do I want to do. Let's say I want to subtract these numbers. So you see, based on my result, I got this answer. So what happened here is that it just simply went towards executing the else statement. So I didn't have to check this operator twice because I already know there are only two possibilities. So why should I waste my computational ability by checking the same thing twice? This is one example for you. So let's say this is calculator one. So let's do the same thing. Let's say this is the second version of the calculator that you're building. And it can do three, or let's say it can do four things. So you are adding more multiples here. So you are just saying, oh, wait, let's just do like this. So now you can add, subtract. You can multiply as well. And you can, let me put an R here, and you can divide. So it's a calculator that can do these four things for you. So now, even here, so now you have to check all of these conditions before doing anything. What you can do here is that you can put here an if statement. So an if statement, you know, it means that you just check one condition, you execute the body, and that's it. But what I like to do here is I like to put an elif statement instead of doing an if statement. So let me write it, and then I can explain you. Or let me build this with the if statement, then you can do the same with the others. So, yep. And then I have the false one. So the operator is multiply, and then the operator is divide. Multiply, divide. Multiply. So let me run this. And what I have to do is I just have to say, I just have to call this function calculator2. and run this. So 5,000, 15,000, let's say we want to divide. So what happened here? It did the operation what I wanted to do, but how did it execute is very important. So what happened here is that it went through all of these operators, all of these conditions, because you have if. So I provided the last one, divide, but it didn't go directly to the last one. It looked for every condition and said, okay, did the user want to add? So this return false. So no. So then it went there. Okay, you want to subtract? No, false. Then you want to see, you want to multiply? No. You want to see divide? Yeah, okay. So you go here, you execute this statement. So this can be very expensive in terms of computation when you are executing bigger conditions that take more time when you are executing conditions. So you want to avoid that. How you can do it? So first and very basic idea was this one. So you check only once, and then if you have only one condition and you have two separate line of codes, it's very easy. You just only check it once and then you can do it. So you avoid half the time. Yeah. Here you can do the same. You can avoid the time. So let's say, and the idea is very simple. You just put here elif, and you just put here elif. And if I put here elif as well, what does it do is that it comes here to the first one, it executes this condition. If this condition is not true, then it goes to the second one and it checks this condition. If this is not true, it will go to the third one. But if this is true, it will not go further. But in my previous example, if I do it like this, and let's say I do it like this. So let's say even if I asked for a summation plus, it came here, it looked, okay, I want to add. It will do this statement, but it will again go here to look for the condition and it will, okay, this is no, so it will go again here. So it will move here. So it will check all of the conditions and that costs you. So to avoid that, we use an if statement. So that's very easy. And you want to avoid the checking of the last condition. So the better thing is that you just use an else statement here. Because of course, if it wasn't these three conditions, it's the last one. What else you can have? Okay. Or maybe you can, if you want to be more on a safe side, you can say it like this. And then you can enter this thing saying else print and you can say here wrong operator, please enter again. So you see that's how it works. So now you check all the conditions. If they are not met, then you tell them, okay, if nothing is met, what you want to do. So you want the user to enter this again. Okay, so let's now let me run this, and now let me run this. So let me see macro numbers, and let's see. I enter an operator that is not here. So what will happen? So you see, it told me wrong operator, please enter again. But it didn't provide me with the opportunity to go back to enter the operator again. So what do I have to do here? It's very simple. Here comes in the while loop. Because you want this thing to be executed again and again. You want to ask the user again and again until he enters the right operator from these four options. Yeah. You don't want it once or twice. You want to keep on again and again asking. So what you do here is that you come here, you put a while loop here, and you say while, and what is the condition that you want to do this again and again? So let's say I take a dummy variable, let's say I, and I say here true. So now my I is true, and I put here while I. So when it comes here, it checks its condition. I is true, so it will go inside, and it will come here to see what's going on. So okay, we have to indent everything now. So you indent everything so that now it becomes the body of the while loop. So if this condition is true, it will go inside and it will ask you for the operator to enter the operator, and then it will go through all of these statements. Okay, so let's run this. So let's say any number. So you see, it asked me to do this again. So now I enter the right operator plus. Okay, it solved the problem, but it went back asking me to do the same thing again. Why? Because I have set I to true and I didn't change the condition of the I. So what I want to do here is that I want to go here. I want to say if this condition is met, execute my statement. Go here and put I to false. I want to do this for all of these so that it won't be executed again. Yeah. So I just do this and let's run this again. Okay. Yeah. Great time. Lost the connection with the server, so I will just copy this. I will open a new server. So coming back to you until I get the connection with the server. Yep. So let me share this with you. Okay, so we are here now. So I say run this, and then I say run this thing. Okay, what happened here? I didn't enter these brackets. So if I don't enter these brackets, the Python thinks of this as a variable, and it goes there, and that variable returns you this, and it tells you, okay, it's a function. So if you want to make it a callable, if you want to call it, you have to enter these brackets. So now it will call that function. So now it's no longer a variable, but it's a function. So let's run this. So just input numbers. So now let's input wrong operator. It asks me again. Now enter the right operator. So you see, it did its job and it exited. It didn't go back just because I put this as false. So this condition is false. It will go back. It won't go inside further. So now you want to see nested statements, conditions. Let's say, okay, before that I think today I will take a little bit longer than usual, but it's interesting. So let's learn something new. So here, when we are making this calculator, we have assumed that the user is entering only integers But numbers can be float as well. User can also enter a float. What we want to do if it's a float or an integer, we don't know. So we want to be very specific. So I can introduce you with a new function. So that will help you to understand. This new function is instance. So let me ask Python. Let me take a help on this function. Returns whether an object is an instance of a class or of a subclass. And you see, you can give this. You can give the arguments as a target to check against this is equal to instance XA. Okay. So let's say, let's try this function out. So let's say I enter a equals, and here I'm entering a float on 10.022. And I want to see if what I entered is a float or not. So a comma. Here I have the second argument is the data type. So I have to enter the data type that I want to see. So I say, let's say first we ask it if it's an integer or not. So false, it's not an integer. The provided number is not an integer. Let's see if it's a string. So data type for string is just str. So you see, yes, it's a string. Let's see if it's a float. False, it's not a float. So that's how you can see if if you have something stored in a variable, you can check the data type of that something by calling this function is instance. So now we want to see if our input string is a number or not. And we want to understand that. So yeah, let me look for a function. I have forgotten. Okay. Yeah. So okay. So I think there is no function for checking that, but anyways. So you want to avoid this. Let me avoid this as well. So we have something called try and accept in Python. So let's say first I ask it to try to convert my number to an integer. And if this doesn't happen, then I say accept the error and convert my number to a float. And I do the same for the others. So I say try, convert it to an integer. If it can't do that, then convert it to a float for me. So that is a thing provided by Python, that if this number cannot be converted to an int, this will result in an error. But when I use this statement try and accept, this thing will not result in an error, but it will go to accept condition and it will try to convert it to a float. So let's see what happens there. So my first number, my second number, my operator. Okay, it worked fine, yeah, because I had inputted an integer. So let's input a float here, 50.22, 60.33, my operator. So you see, now it worked very well. How it worked very well? You can even ask for Python to print the type, the data type, I mean. So the function that you use to print the data type is at type. Sorry, help type here. So what does it return? Yeah, that we are interested in. So yeah, this one. So you insert the object that is your variable, and it gives you the type of the object. You don't need to read all this. Okay. Anyway, so let me just remove this one. Let me remove this one as well. Okay. So yeah, after this, what you can do is you can print, and you can say type of A is, and comma, and you can just call this function type A. You can do the same here, and you can call for the type of B. And you know A, okay, so yeah, let's say first number, and let's say second number. Okay, so now I run this one. So let me enter an integer first, and then I will enter a float. So you see, type of first number is an integer, and the type of second number is a float. You see this string here, float, and this string here is integer. So, and whatever you want to do, you want to divide or add or something. So that's how you can build a calculator based on try and except statements and based on while loop. And also you can check multiple conditions as well. So nested conditions are very simple to understand. Let's say if you want to see that a user enter. So let me ask one thing from the user. And let me say input. So we ask them enter your discipline here. And then B, we say enter your subject. So now you want to say that if the user entered engineering as a discipline and they entered, let's say they entered electrical as a subject, so basic electrical engineering is a subject that I have taught and during my teaching times. So this subject belongs to this discipline. Yeah. So we want to say that if first we check the discipline A, and let's say my discipline is engineering. And the second condition that I want to check is if my subject entered, so let me say is electrical, print, let's say hooray, Okay. And what happens if you don't? It's just that, let's say, okay. So I have already explained you how to go back. If you want the user to try again, you can use a while loop and you can go back and ask them the same question again and again. So I'm not going there. So the idea is that I explain you the nested statement. So I will run this. So let's say I enter engineering, then I enter electrical, say enter. So hooray, you are an engineer. Okay. Yeah. Okay. So I run it again. Let's say I'm saying I want to go to engineering, but I want to study biology. Okay. For the moment, we consider that biology is not part of engineering. So I run this. Okay. Sorry. I should enter. Yeah. So you see, okay, try again. So what happened here was that first statement was met, but second statement was not met. So it didn't go here, but it exited and it came here. So let me print something here. Yes. Okay. I run it again. And I do the same thing. Okay. So what happened here? It should have printed this statement, try again. But it didn't print this statement. Why? Because when I enter engineering, so it came here, it compared A with engineering, and this was true. This condition was met. So it went inside and it printed this statement, yes. And it went there to look for this statement. And this statement was not true. So it exited this whole thing. Because this else belongs to this if statement. And this if statement was true, that's why it went there. So you see, that's how it works. So if I want to print this one, so let me put this one here. So now this is else statements belongs to this if, not this one. And I run this again. Okay, let me make this ing to avoid typing it again and again. So okay, yeah, let me restart this one. So let me delete this one as well. Just copy this and run this. So my discipline is engineering. I'm a student of biology, let's say. So now it printed this statement, try again. It printed this statement, yes. And it went here to check for the condition, and this condition was not met. So it went to the else condition and it printed this statement. So that's how you can play around and you can learn nested if else statements as well. So this thing is called a decision making tree. So you can call it a tree. So because you are checking one condition, then you go and you check another condition. So based on this tree, you make some decisions and you do some things or you don't do something. So that's how it works. So I think that's enough for today. I think it's a lot. We have learned loops. We have learned both for loop and while loop, and we understood how to use nested loop, and we also understood when to use which loop as well. And then we also learned conditional statements, if and if else statements, and I showed you a bunch of examples. Okay, you can try at home. You can try this example, simple grading scheme, where you can divide a set of numbers starting. Let's say you say, okay, if you are above 40 and below 50, you pass. In 50 to 60, you have certain grade, and 60 to 70, you have certain grade. So you have conditions. So you can set up conditions, and based on the whatever number user inputs, you should be able to tell him the grade. So your program should be able to think how to grade based on the input number of the user. So it's a very good exercise you can do at home after this. Yeah. So let me just show you one more thing. Let's say we have this one, and we have a list of provided disciplines that our university is offering. Let's say we have engineering. Let's say we have oh wait, avoid this one. So we have biology as well. We have I don't know. We have mathematics. So we have biology. We have engineering. Or you can go on adding to this list. You have business as well. Okay. Anyways, so you ask the student to enter their discipline that they want to study, and then you tell them if their discipline is available or not. So here, what you have done is you have entered the discipline in full, and your first letter is capitalized here. But the user can input anything. They can input, let's say, they can input first three letters, and they can input them as a lowercase or uppercase or whatever. So one thing that I want to show you is this one. Let's say I have a string. This one. What you can do here is you can use a property of this string, and you can convert it to lowercase. Okay, it doesn't have this lowercase. Let me see what is this. Okay, it's just you just have to enter lower. That's it. So you just say this. Yeah. So you see, it converted this string to lower, and let's say I have this string here, and I want to convert this string to upper. So I just have to say b dot upper. So let me run this. So it converted the string to upper as well. So you have seen multiple examples of how to do these things. So now here the user entered their discipline, and they can enter in whatever case they want, lower, upper, or they can enter first three letters or four letters or whatever. You want to see if this thing belongs here or not. You want to tell the user that if you are offering this course or this discipline or not. So you will have a bunch of if-else statements here that you will use to compare this one. So first, let's say you want to see. Okay, let me just use this. What you do here is that I just want to check one thing. Okay, yeah. So I convert my input that was discipline to lowercase, lower, and then I don't know if user entered 3 letters, 4 letters, or whatever. So let's say we ask them to enter minimum 3 letters. Let's say here. Okay. So and then, but they can enter 4 or 5 letters as well. The minimum is 3. So you first you want to have a check. Let's say length of A is simple, length of A, and you do the same thing. Like if length of A is less than 3, it's very simple. You just ask them to try again, and then you can use the while loop that I have explained you to do this again. And so now you have got the length of the letters, and you want to see if they match these letters, they match the ones provided in this list. So one very simple thing that I want to do is, so let's say I use this trick always. So I equals, I put this as false, or let's say I call it a flag. So it's a flag. I start from false, and then say for every item in the list that I have, what I want to do is that I say convert that item to the number of to the length of this one, length of it. Yeah. So let's say first I say item equals item, and then I use this thing that I have explained you before. I say start from 0 and go to the length of it. So okay, this thing here is called hashing. So you are hashing the string. This string, you hash this string, this string. So anything that is countable is hashable as well. So a list is countable, so it's hashable as well. So now you got this item that was exactly the same number of letters inputted by here. And another thing that you want to do is that you want to convert this to a lowercase, so you don't, because in Python case matters, so case of the string matters. So you convert both the strings to lowercase, and now you say if my item equals the string provided by the user, just put this flag to true. So what happens here is that for loop comes in and it will execute this statement for every item present in this one, no matter, let's say the user inputs eng. So at first it will set this flag to true, but then it will go back to do for all of the items. You want to avoid that. You want to look for only that item which matched, and then you want to stop. So that's where it comes in the while loop instead of a for loop. So what you want to do here is that just a bit of a logic. You play with the logic here, and you say my flag is true, and instead of using the for loop, you use a while loop here, while, and you just say flag. And there's a bit of a trick here. What you want to say is that you want to count. So you want to have a countable with you. I equals 0. And then you want to say pick the item from the list So list L, and the item, which item you want to pick? Ith item, this item I. And then you want to do, what you want to do here is, you want to say, you want to increment. So it's just counted for, and then you want to say here, you want to check if, you just check flag. Okay. So one thing that I should do here is that I put this flag true here. So if I want to exit the while loop, I should put false here. Now here is a trick. You can do two things. Okay, I will tell you. So now I know that if my flag was true, it means none of the discipline was found. So it means the user choose a discipline that is very different that I'm not providing. So it means this flag will remain true because this condition will never be satisfied. So if this flag is true, it means I don't have this discipline. So we just say, sorry, we don't. So here is another thing. In Python, if you want to enter quotes, so you see, as soon as I enter this code and I enter T, this thing is in red and this thing became black. Because for Python, the string ended here and here is something else that Python doesn't know. So you want to avoid that. What you want to do here, you enter double quotes and then you enter T. You see, now it's a T. So now it thinks it's a string. So you can do two things. Either you can put the whole thing in double quotes, then you will have to use a single quote here. Or you can do it like this. I'm very used to this one because it's very simple to use. So okay. So now, and you can say here else. You can say print, and you can say congrats. So it means you have that discipline and you're saying congratulations, you are a winner. Okay, so let me run this one. Okay, there was a problem. Yeah, so we didn't enter the closing statement here. So I'm not sure any problem. So let me say I enter math and then I press enter here. Something is wrong here. List index out of range. What happened here? It means that it was counting one and it was adding 1, 1, 1 all the time. And it reached a point where it added 1 and it couldn't find more elements there. So it says out of index. You see index out of range. So it means you have reached the length of the list and you can't find more items there. But why did it happen? Because of this, I converted this item to lower, but I didn't store it back to item. So all I have to do is this. Now I should be fine. So let's say I choose math again. And it's not defined. Okay, why? I should put item here. Item. What is going on? Something is wrong here. Let me try again. Item dot. Yep. Okay, so I run again. Same math. Yeah, so it worked. So you see the execution time will be very less in case of while loop, but it depends on the usage, how you want to execute. Right? In some cases, for loop can have a less execution time instead of a while loop, and in some cases, while loop can have a less execution time instead of for loop. It just depends on the application, how you want to use it. For example, here it's very clear that you don't want to go over every item once you find what you are looking for. So let's say I run this one again, and this time I enter a discipline that is not provided in this list. So let's say I want to be a doctor. This I'm just saying. So what happened here? We ran into errors. What is the error here? Again, list index out of range. Yeah, that is very interesting. What happened was that it was trying to look for doctor in this list, but it never found this doctor. So this condition was never true, so it never went to false. So this condition was never false. So what we want to do here is that we want to avoid going further once once I have checked all the list. So it's very simple. I just have to know the length of my list. I have to say here, and here. So now instead of checking one condition, I have to check two conditions. One is that my flag should be false to avoid this. And we have already discussed that we have the different operators that we can use here. And the AND operator is very good. In this case, in this very specific scenario, I need the AND operator because I want both conditions to be true to go inside the loop. If any one of the condition is false, don't go inside the loop. So AND, I use AND. So I just say AND, and I say I. Okay. Here you have to be very, very careful what you want to look for because you're saying every time add one. So if you see here, the length of this list will be 1, 2, 3, and 4. 4. It will be 4. But the last item, the index of this item is not 4, it's 3. So if you are looking for the fourth item here, so if I say and I is less than length of L. So this is very clear. Okay, you can even avoid doing this. You can just avoid it by this. You can avoid this line. But what will happen is that, for example, I can write this thing, length of L here, but you are increasing the computation because every time you have to check the condition, and before checking the condition, you have to calculate the length of the list. So every time you execute this loop, you have to check the length of the list. And if you increase the items here, number of items, you increase the number of loops. So you increase, so you can multiply. So you see everything multiplies. So you have to avoid this thing. So the good thing is that you just calculate it once and you just use it here. Okay. So what I'm saying here is that my flag should be true and I should be less than length of L to go inside this loop. Once my I becomes 4 and 4, okay, 4 less than 4, it will be false. So it won't go inside. So let's do this now. I just say doctor. I say enter here. Okay, so you see now it exited this loop and it went here directly here. So another thing that I wanted to let you know is that you have to, so some programmers like to do it like this, but some programmers don't like this. So they want to keep things very simple. So here, some people will use it and will say like this, not flag. So you are using the not gate. So you in reverse the logic. So it means flag was false. It was returned false. But you have to go inside here only when the flag is true. But when it was returned false, you convert this, it will be true. So you will go directly here. sorry, yeah. Okay, if you didn't find, let's say you didn't find the input discipline in this list, when you didn't find, this flag is true. And when you come here, the result will be false. So it won't execute this statement. It will go directly there and to say congrats. It means it was found, but it's wrong. It wasn't found. So all you have to do is just remove this statement and put it here. So it's the same thing reversed. So let's say now I enter something that I found. So you see it went here, congrats. So these are just two different ways to use this logic, but you can either avoid using not, or you can either switch these statements. Like it depends on you how you want to do it. So I think it was very productive session today. Like we have seen the usage of we have to seen how to build a calculator. That let me show you. Can I show you? Yeah, this one. So we have seen how to build a calculator, and we have seen how to use loops and use if-else statements that will benefit us instead of like in terms of what to say this, like in terms of computation burden for the computer. So you always want to code in a way that will avoid the computer to do more calculations. So you always want to make the computer do less calculations, and you want to have less number of lines in your code, because then you take less memory space in the RAM. So you want to have less number of lines in your code, and you want to have less number of executions. You don't want to check every condition. You just want to have a way, some sort of way where you can avoid, like for example, I have explained you can use if and elif statements, and this avoids a lot of um, yeah, checking of the different conditions. So and in the next one, let me go to the next tab. Here, yeah, here you just build a program that that can just look up the data. So this thing here, I just input a list. You can input anything from a file that you can convert to a list, and it can be your lookup table as well. So you have a lookup table, and you look inside that table if you have what you're looking for or not. So it's very simple program. And here you have also learned the usage of for loop or while loop. So I think that this session was very productive, but it was really, maybe it's intense for the new programmers, but you need to start learning. If you start learning from now, you will have very much deep knowledge, and you will be easily moving towards the higher level of programming in Python. That will be advanced level. So this is just a beginner's level. I'm just teaching how to start from scratch, but I have done this tremendous job of explaining you things so that you can and you are able to move to forward towards the advanced level. Okay, guys. See you in the next session. We will advertise whenever is the next session for us, and so you can come back to join the next session. Have a good day, guys.